Why are interrupts vital for Linux systems? Have you ever wondered how your computer responds so quickly to your commands? One key player in this speed is interrupts. Let's break down why interrupts are so essential for Linux systems. Interrupts are signals from hardware or software that tell the central processing unit to pause its current task. This allows the system to address more urgent matters without wasting time. Instead of the central processing unit constantly checking for updates, interrupts allow it to react immediately to important events. When an interrupt occurs, the Linux kernel steps in. It temporarily halts what the central processing unit is doing and runs something called an interrupt handler. This handler is a special function that quickly processes the interrupt. This quick response is vital because it prevents devices from stalling and ensures that time-sensitive tasks are handled right away. Linux has a structured way of managing interrupts. First, it acknowledges the interrupt while disabling further interrupts to avoid conflicts. Next, it runs specific handlers for the device that triggered the interrupt. Finally, any less urgent tasks are pushed to the background for later processing. This layered approach keeps the system responsive and stable, especially on computers with multiple processors. Every device that can send interrupts has its own handler, usually written in the C programming language. These handlers operate in a special context that cannot be interrupted again. This design allows the kernel to service hardware requests without delay and quickly return to the original task. Interrupts are crucial for multitasking environments. They let Linux handle various events like keyboard inputs, network packets, and disk operations without wasting central processing unit cycles. This efficiency makes Linux suitable for a wide array of applications, from small embedded systems to large servers managing many connections at once. In summary, interrupts are vital for Linux systems because they allow the kernel to respond quickly to hardware events. This responsiveness supports multitasking and efficient device management, setting Linux apart from simpler operating systems that rely on slower methods. Understanding interrupts helps us appreciate the seamless performance we often take for granted in our computing experiences.